Hello there, Mr. Wilson here again for what is the first lesson in this new video series known as Bridging the Gap. So in these videos, as I was explaining in the introduction, I'm going to attempt to bridge the gap between GCSE maths and A-level maths, because for some students it can be quite overwhelming, and we obviously want to make sure we're prepared for that A-level in September. So you might have just finished your GCSEs, you might be in the some holidays, you might be 1 week from starting in your new course, wherever you're at. Hopefully these videos will give you a bit of an idea of the key skills that you might need. So this first lesson is on indices, powers in other words. So we're going to look at the laws of indices, we're going to recap those. We're going to recap some key ideas that I need to know for A-level. And all of this is GCSE content, so none of this should be new to anybody who has done their GCSE. But I obviously understand that, people who are taking A-level maths, there might not be a requirement, like a minimum grade to do your A-level course. There might be a minimum grade. You might need a grade 6, 7, 8, maybe even a 9, depending on what college you go to. So people watching these videos might have a range of abilities, and hopefully anyone of any ability will be able to sort of pick up this. Okay, before we start though, make sure that you subscribe so you don't miss out on any of these. Let's jump straight into it. So, first thing, let's talk about the laws of indices as they're commonly referred to. So the laws of indices, right? There are sort of three key laws. The first law, and there isn't really any particular order. This is just the order that I've always taught it in. When you have two powers with base numbers, so let's say we have x to the power of a times x to the power of b. So when you times two powers but the same base number, then you add the powers. Okay, so what I mean by base number, by the way, and actually this will become really important in A-level, because you taught more about what a base number actually is, and that then leads on to logarithms, and that wonderful link between powers and logarithms is really interesting. But so it is important to know what the base number is. The base number is just the number that we're raising a power to. So in this case it's x is the base number, but it could be a number, it could actually be 2 or 3, and then obviously the little number is the power. So in this case, x to the power of a times x to the power of b, we would add the powers. So when you multiply, as long as they're the same base number, you add the powers. The second law, if you have two terms with the same base number, but you are dividing them, then you subtract the powers. So you do a take away b. And the third law, when you have a term in the brackets raised to, so a term with a power in a brackets raised to the power outside the brackets, you multiply the powers together. So in this case, if a was 5 and b was 2, you do 5 times 2, which is 10, so it'd be x to the power 10. So we should hopefully be sort of familiar with these laws and how they work. Now, obviously, at sort of the higher end of GCSE, and we'll look at some questions in a second, they like to combine multiple laws of indices together in one question. So you might find that there's a multiply and a divide in one question. You might find that there's a brackets and a divide, or whatever. They like to combo these laws together. But these laws, like I've already mentioned, are really vital for A-level, because you realise the link between powers and logarithms. There are also some essential key facts about indices that you should know and need to know for A-level, that will also make sure that you set up nicely. But just a reminder that laws of indices, log laws of indices, it's a wonderful combination, and like I said, once you get to that stage, you'll realise why this is so important, and it's so important to have those fundamentals ready so that when you do move on to something more advanced, that the foundations are already there. So the key facts then, that I wouldn't necessarily call the laws of indices, but obviously they are linked to powers. So let's call them fact A, because then we don't get confused with the laws. So fact A, anything to the power of 0 is equal to 1. As long as x is not equal to 0 itself. That is the only exception. And again, the reason why it can't be that links to logs as well. So logs and powers are like the inverses of each other. But there is a key fact there that tells you why you can't do 0 to the power 0 and say that it's equal to 1. But as long as x is not equal to 0, anything raised to the power 0 is equal to 1. Another key fact, anything raised to the power of 1 is itself, which is a nice little interesting idea. Anything raised to the power 1 is itself. And this does include 0. 0 to the power 1 is still 0, and every other value as well. Now, this is where we start getting into some more interesting ideas. If you raise x to a negative power, okay, so let's say negative a, then this is the same as 1 over x to the power of a, right? It is the reciprocal of x to the power of a. So when you raise something to a negative power, you take its reciprocal. So for example, if a was 2, then x to the power minus 2 would be 1 over x squared, or whatever x might be in this current situation. So the key idea here is that a negative power is the reciprocal. So you just, I was going to say flip it over, but that is the very naughty phrase that that we shouldn't say as teachers. But you basically just put it as 1 over. Or if the actual term is already a fraction, so for example, if it is x over y to the power of negative a, then it becomes y over x to the power of a. Well, to the power of a for the whole thing. So basically you just take the fraction and change it over. I'm going to remove that just because otherwise it'll ruin my lovely neat rules. The next one then, if you raise something to a fractional power, so for example x to the power of a over b, right, where a over b is a fraction, as long as b is not 0, because then it couldn't be a fraction. So x to the power of a over b, then this means, right, that you do the bth root of x to the power of a. If that doesn't really make much sense, let me give you an example. So let's say, for example, that I have x to the power of 3 over 2. That means I would do the second root of x, which is the square root, because it's the standard one, so the square root of x, raised to the power of 3. So I would, take the square root of x and then I'd raise it to the power of 3 and do it like that. If it was the other way around, so if it was x to the power of 2/3, I would take the third root of x, the cube root, and then I'd square it, and I'd get something like that. So it's important that we make sure that we understand fractional powers, because again, fractional power is a huge part of A-level maths, and as you sort of progress further on in your studies, you kind of realise that these sort of nasty answers that you would think are suspicious at GCSE. So what I mean by this is, for example, if you get an answer that's a horrible fractional power, at GCSE you'd think, that's probably not right, I've probably done something wrong, it can't really be that. Whereas at A-level, they tend to be more common, and it's important that we understand and recognise these rules, and that we sort of accept that at A-level, really the answer could be anything. I mean, I've seen some absolutely horrible answers for questions at A-level. And what I mean by that is that you look at it and you think that can't possibly be the answer. It's just so weird, it's so different to sort of anything you might have seen before. But I think we've just got to open up our minds and think, that probably can actually be an answer there. So I think these are basically covered all the major ideas. So again, we just need to know our laws of indices, and then we also need to know our key facts about powers. So what I would like you to have a go at then is and I would grab a pad and a pen now if you don't have one, is I want you to have a go at some of these questions. Now, these questions are by... actually, I will have a go at some of these questions, and then you'll have a go at the next one. So these are provided by Physics and Math Tutor, a fantastic website, so shout out to them. And they've selected some Edexcel GCSE maths questions. So these were already on the past papers. These are all GCSE questions. They've just selected them from the past papers. So let's have a look at some of these then. So we'll start on the first page, and I'll do the second page as well, and then I'll give you some to have a go at. Right then, question 1. P to the power 3 times p to the power of x is equal to p to the power 9. Find the value of x. Well, according to the first law, if you times, you add the powers. So 3 plus x must equal 9. So we can immediately say that fact. And it's very easy to spot that x has got to equal 6. So it's got to be p to the power 3 times p to the power 6 is equal to p to the power 9, because 3 plus 6 is 9. I mean, the most common incorrect answer here is 3, because students think when it's a multiply, you times the powers, because they just see multiply, when really the law says that when you multiply, you add the powers. Okay, let's have a look at the next one. 7 to the power 2 brackets all to the power of y is equal to 7 to the power 10. Find the value of y. Well, according to the third law, as I number them, the third law, when you have brackets, you multiply the powers. So 2 times y has got to equal 10. Well, in this case, therefore, it's quite easy to spot that y has got to be equal to 5, because 2 times 5 is 10. So y is 5. Okay. This last one, though, is very interesting for a lot of good reasons, and I'll explain why in a second. So hopefully, just so we're all on the same page, hopefully those two first questions were sort of quite self-explanatory, using those laws of indices, just making sure we know them. That's what really this question is testing. This last one, though, is quite interesting. 100 to the power of a times 1000 to the power b can be written in the form 10 to the power w. Show that w is equal to 2a plus 3b. Now, right now, you might be tempted to say, well, I'll just add the powers, right, because we're multiplying. Remember, the key fact is you can only use the laws of indices if the base numbers are the same. And in this case, we've got 100 and we've got 1000, so the base numbers are not the same. So we can't use this law. But we can if we sort of change it into a different form. So if we know the key fact that 100 is equal to 10 to the power 2, 10 squared, 10 times 10 is 100, and 1000 is equal to 10 cubed, 10 to the power 3, 10 times 10 times 10, then what I can actually do is I can replace this 100 with 10 squared, right? So I got 10 squared to the power of a plus, times 10 cubed to the power of b. And remember, we can use this third law that when we've got brackets like this, we times the powers together. So we get 10 to the power of, well, 2 times a is 2a, times 10 to the power of 3b. And apparently this can be written in the form 10 to the power of w. Well, now that we've changed it, and this is quite a common technique, by the way, a more advanced level, changing stuff so that you can use a rule, quite a nice idea. Now we can use the law of indices because we've got the same base number, so we just add the powers. So 2a plus 3b must equal this power here, w, which is exactly what they've asked us to show. So this is as shown. So a nice little idea there, changing something to then allow you to use a rule that you already know. Very common at A-level, very, very common, especially with trigonometric identities, as they're known, using like a rule to swap out the trig identities for ones that you can actually work out. And that's a really, really common idea. So, obviously we have to be aware of that idea and make sure that that is part of our toolkit. Okay, let me have a go at some of these and then I'll give you some to have a go at. So, write down the value of 36 to the power of a half. Well, to the power of a half, remember the denominator tells you what root you take. So I'm going to take the second root, the square root of 36 is 6. And then I'm going to raise it to the power of 1. Well, according to the fact that we discussed earlier, anything to the power of 1 is itself. So this is just going to be 6. So really, anything to the power of a half just means take the square root, because when you raise it to the power of 1, you just get the same value. Write down the value of 23 to the power of 0. Again, a key fact that we should know. Anything to the power of 0 is 1, as long as the base number is not 0. So this is going to be 1. And then finally, work out the value of 27 to the power of negative 2/3. Well, first thing, let's sort out that negative. Well, the negative means to take the reciprocal. So I'm now going to be working out 1 over 27 to the power of 2/3. And to the power of 2/3 means I'm going to take the cube root of 27, which is 3, because 3 times 3 times 3 is 27. And then I'm going to raise it to the power of 2, because it's 2/3. So I get 9. So 27 to the power of 2/3 is 9. So the answer is 1 over 9. Nice little answer. So what I would like you to have a go at then is, let me just see if there's some interesting questions here. Some nice ones, actually. Right then, I'm just trying to select. I've not really looked through these. Yeah, these ones look ideal, actually. Yeah. So question 10 here. 10A, B, C, and D. These questions look ideal. So what I will ask is, I recommend you pause the video, give these questions a good go, and then we'll reconvene in a second and figure it out. So pause the video now, and then we'll talk through the answers. So hopefully you've had time to have a go at these, and let's go through some of them. So write down the value of 7 to the power 0. Again, anything to the power of 0 is 1, so that's just going to be 1. Find the value of 3 to the power 3 times 3 to the power 6 times 3 to the power negative 6. Well, when you multiply, as long as you've got the same base number, you add the powers. So this has technically got a power of 1 because it's itself, and anything to the power of 1 is itself. So 1 plus 6 is 7, plus negative 6 is 1, so it's going to be 3 to the power 1, which is just 3, because anything to the power 1 is itself. In other words, this 3 to the power 6 and this 3 to the power negative 6 basically cancel each other out, just leaving you with this 3 value. Write down the value of 2 to the power negative 4. Well, the negative means to take the reciprocal, so you do 1 over 2 to the power 4, and 2 to the power 4 is 2 times 2 times 2 times 2. So we get 1 over 16 is the correct answer. And then finally, find the value of 27 to the power of a third. Well, to the power of a third, you take the third root, the cube root of 27, which is 3, and then raise it to the power of 1. Well, anything to the power of 1 is itself, so this is just going to be 3. Now, there are some really, really nice questions in this selection. Like this one, for example, this question 8 here is really interesting. These ones are really interesting. This one's really interesting. So I'm not going to sort of make you have a go. I mean, feel free to pause the video now and have a go. But what I would rather you do is go on to Physics and Maths Tutor and get it from their website, because obviously these are their questions, and it's only right that we acknowledge some fantastic questions here and have a go at that. But all this lesson was really to provide is just that reminder, that insight into some key facts that we need to remember. So hopefully you've enjoyed this video. If you have, then definitely check out all the other videos on the channel. There are loads of videos now, and hopefully there'll be many more of these bridging the gap videos that will be useful and help you with making sure that we're ready for A-level. But like I said, it is a different style of video to what I normally do. I normally do paper explanations. So if you have enjoyed this, then please let me know if you find this useful, because then I'll obviously keep doing more of them. But yeah, all I want to say is thank you so much for watching, and I hope you have a fantastic day.